All right, welcome to our first notes on video lesson. This is section 8.4, proportionality theorems, wrapping up chapter 8, similarity with some simple proportions that are found inside triangles whenever you bisect an angle or draw a line parallel to one of the sides. And the first one deals with the parallel concept. So T does not have to be the midpoint of QR. Nor does U have to be the midpoint of SR. Those are just anytime you divide a triangle with a segment inside and stay parallel, then you have a proportion that results from that. And the converse is also true. If you know that the segments are proportional, these two and these two, then you can conclude that the lines are parallel. So let's take a look at a couple examples that illustrate each of those theorems. And our first one, all right, pretty simple stuff here. So again, we are given the parallelism. QS is parallel to UT. So we want to try to find the missing segment of RQ. So our theorem tells us that RQ is to 9 as 4 is to 6 based on the numbers in the diagram. So cross multiply. So 6 times RQ equals 36. And let me get rid of that equal sign there, friends. All right, and then when you divide both sides by 6, of course, RQ equals 6. Pause the video here, try the monitoring progress, and pick it back up when you're done. All right, for me, I'm going to keep rolling here, people. So now I'm looking for YZ. So 35 is to YZ as 44 is to 36. And don't be afraid of decimals when you cross multiply here. You've got YZ equaling 28.6. I just rounded to the nearest tenth. And so there you go. All right, now again, talking about the converse of this theorem, we should be able to tell, given all of these dimensions in example 2, is this shoe rack going to be parallel to the bottom of the floor? So BD, is this going to be parallel? Remember, don't judge by appearance. Use what you know in your theorems and geometry to determine whether or not the segments are parallel. So I'll just fill some things in here. So BA was, this part was 33, CB 27, CD 44, and DE 25. Now, again, we're not sure if they're parallel, so we are checking the proportions. So when you ask yourself, 27 is to 33, is that the same, is that proportional to 44 over 25? And the easiest way to do this, guys, is just cross multiply. Does 27 times 25 equal 44 times 33? I think not. So you'd answer that question as no, it is not parallel, silly. Again, pause the video here and try the monitoring progress, pick it back up. And I'll be doing it here. Let's see what we got. In this one, we want to check and see if 90 over 72 equals, that's a 0, 50 over 40, and when you cross multiply this one, you get, yes, they do indeed equal each other. All right, so there's our second concept today. All right, moving along. We have an extension to the last theorem using the proportionality theorems. If you have multiple parallel lines, so in this case we have 3 parallel lines, this would work the whole entire way across if they were all parallel. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So in this case, in example 3, angle 1, 2, and 3 are all congruent. Aha, so that's essentially giving you parallel lines, right? Corresponding angles. So sometimes they'll give you the arrows like they did there. Sometimes they'll come out and tell you that, hey guys, you have angles that are in a corresponding position and they're congruent. Therefore, aka the lines are parallel. All right, so if that's the case, we should be able to use our proportion to figure some stuff out. We want to get h to f, all of that. That's what we're looking for. So to do that, we want to find gh. So I'm going to just throw some variables in, make this a little bit easier. So set a proportion up to solve for y. And I can simply say that 120 is to y as 150 is to 300. And you might not even have to cross multiply this one. 150 is half of 300, so 120 is going to be half of what's on the bottom. So I know that y is going to be 240, just using my head there a little bit. And so if y is 240, then the entire length of hf would simply be 120 plus 240, or 3, oops, again with the sloppy equal sign, 360, and I'm in yards here if you're keeping score at home. All right. All right, and our last example, we have the triangle angle bisector theorem. A lot of words there, huh? Triangle angle bisector, it's wordy, but basically anytime you bisect an angle of a triangle, and you cut the opposite side into two pieces. Again, D does not have to be right in between A and B. You divide the side proportionally with the other two sides of the triangle. So for instance, AD is to DB as the sides CA relate to CB. So now in example 4, let's see what we got. Well, let's see. Oh, this is a good SAT type thing here. So 15 is the entire length of Q to S. So therefore, I can represent QR in terms of X by calling it 15 minus X. So that's an important concept to remember on your SATs. They'll ask you to do that from time to time. All right. So again, using the triangle angle bisector theorem, I can set a proportion up. I can say 7 is to 13 as 15 minus x is to x. So 7 is to 13. So this piece is to this piece as this piece is to this piece. So cross multiply. Don't forget to distribute. Here, my friends, we have 13 times 15 minus x. All right, so that's a 195. So 7x equals 195 minus 13x. Add 13x's to both sides, divide by 20, and x is, it's a decimal again, right? 9.75. And that's okay. It's allowed to be. So there you go. So there's the length of our S right there. Okay, pause the video and try these problems, and then I'll fill them in for you whenever you're done, whenever you click back in. All right, so here we go. Little setup here. We've got 16 is to BD, and 40 is to 30. That's a 4. This pen's tough. So BD is 12 in this first one. All right, the next one, I'm looking at 16 is to 15 as JM is to 18. And that gives me a value of 19.2 when I cross multiply. All right, number 5 down here, I have 24 is to 14 as 48 is to x, and that gives me a 28 on that one. Can't live with that, that's too messy. And again, that is a 28. And the last one, 4 roots of 2 is to 4 as y is to 4. And it's another one you can use your head. The denominators are the same, so the numerators will have to be the same as well. So that's 4 roots of 2 on that one. All right, guys, that's a wrap on our first video lesson. Hopefully I'll get a little bit neater with this pen writing on my surface. All right, peace.